Welcome back. So, today we're diving into, well, frankly, one of the most intimidating books you could probably name. Ambitious, yes, but also famously difficult.
Oh, absolutely. It's one of those works that people talk about more than they actually, read.
Exactly. It sort of feels like it could collapse under its own intellectual weight, but somehow it completely reshaped things.
It really did. And you could argue the source material we have today isn't just about a book. It's more like an event, a huge philosophical quest.
A quest. I like that. We're taking a deep dive into Principia Mathematica. That's the massive three-volume work by Alfred Whitehead and Bertrand Russel.
Yeah, their attempt to basically establish the ultimate foundations of mathematics, like from the ground up.
So our mission for you, listening right now, is to walk away knowing what the revolutionary heart of this thing actually was.
Right. We want to pull out the core genius. What were they trying to prove? What problem were they even trying to solve?
And why does it still matter today? Without, needing to wade through hundreds of pages of symbols yourself.
hmm And its influence was pretty much immediate. Our sources all agree the Principia is seen as this huge intellectual landmark of the 20th century.
A landmark, okay.
Yeah, fundamentally shaped, well, everything that came after it in mathematical philosophy. But to really get why it's a landmark, we kind of need to look at why they even bothered writing it.
Good point. Let's maybe start with the sheer scale of it. This wasn't exactly a weekend project, was it?
Huh. No, definitely not. We're talking about two absolute giants, Whitehead and Russell, collaborating for years.
And the volumes themselves came out over time.
That's right. The first edition, the main three volumes, that was published between 1910 and 1913. So even just getting it out took a while.
Okay, 1910 to 1913.
But even that wasn't the end of it. Things were moving so fast and the discussions were so intense that they actually put out a heavily revised second edition.
A second edition, when was that?
That came out between 1925 and 1927. So, the whole project from initial ideas probably way before 1910 to that second edition, it was easily a decade and a half, maybe more.
Wow. Okay, so those dates, they tell a story, don't they? It's not just a publication schedule. It suggests they were wrestling with something big.
Exactly. It signals the intellectual turmoil going on. They weren't just writing like an advanced textbook. They were trying to rescue the very certainty of mathematics.
Rescue it. What was threatening it?
Well, context is key here. By the end of the 19th century, the foundations of math, especially this new thing called set theory, started to look shaky.
Shaky how?
People were finding paradoxes, logical contradictions. The most famous one is actually Russell's own paradox. It showed that the way mathematicians were defining things like sets could lead straight into absurdity.
So like the fundamental building blocks were flawed.
Potentially, yes. And that created a real crisis of confidence. If mathematics, the supposedly purest form of reasoning, could contain contradictions, well, what could you actually be certain of?
Okay, I see. So Whitehead and Russell didn't just throw up their hands.
No, quite the opposite. They basically said, right, we need to rebuild this whole thing from scratch, using only logic that is absolutely undeniably true.
That sounds ambitious, doesn't quite cover it. It's like an ultimate architectural challenge.
It was immense. And just to give you a feel for the scale and importance, it was still being reprinted decades later, 1950, 1960, 1963. People needed access to this text.
That's commitment from the publishers, too.
And the price tag reflected it. Back then, the set of 3 volumes cost $45, or 12 guineas in the UK. That was a lot of money for books at the time.
That really does underscore the perceived value, doesn't it? Okay, so we've got the physical book, the cost, the reprints. Let's shift to the idea inside it. What was the actual revolutionary claim? The core thesis.
Right. If you boil down all those hundreds and hundreds of pages, all 3 volumes, into one big idea, it's this. Principia Mathematica was the first work to show, clearly and with intense rigor, the incredibly close relationship between mathematics and formal logic.
Okay, close relationship. Let's unpack that a bit, because that sounds important.
It is. They weren't just saying, math uses logic. That's obvious. They were making a much stronger claim. They were asserting that mathematics is logic, or, more precisely, that all of arithmetic, analysis, everything. It's just a highly complex extension of purely logical truths.
Whoa, so numbers, addition, calculus, all just complex logic?
It was the goal, yes. That theory even has a name. Logicism. Before Principia, Math was often seen differently, maybe empirical, maybe based on intuition, maybe axiomatic, but not necessarily grounded in pure logic.
So they were trying to give it this absolute unshakable foundation.
Exactly. The certainty of logic itself. They wanted to demonstrate that any mathematical statement, no matter how complex, was really just a very complicated way of expressing something purely logical.
Okay, but how on earth do you actually do that? If you're saying everything comes from logic, where do you start? What's the method?
Ah, the method. That's probably the most famous part and why the book is such a landmark. They use what's called an axiomatic approach.
Axiomatic, like axioms in geometry, starting points.
Sort of, yes. They aim to show the structure of both math and logic by starting from the absolute minimum number of logical axioms possible, foundational truths.
Minimal axioms. Okay, this sounds like the bedrock you were talking about. It seems simple, but I bet it wasn't easy.
Oh, incredibly difficult. They had to build the entire universe of numbers, everything, using only these tiny, fundamental logical starting points.
What were these starting points? Like, give me an example. Are we talking a straight line as the shortest distance?
No, those are geometric axioms. Theirs were even more fundamental. They were primitive logical ideas. Things like negation, the idea of not P,
Okay.
disjunction P or Q,
Yeah,
and
that-
implication if P, then Q. Really basic stuff that, it's hard to argue with logically.
So from just not or and if then,
Yeah.
essentially,
Yeah.
they're trying to build numbers and addition.
And subtraction and everything else, yes.
Yeah.
Using only those logical tools and concepts derived purely from them, like classes or sets defined logically. It demanded just excruciating formal rigor.
It sounds painful.
It was. And this leads to another famous aspect. To achieve this, to make sure every step was purely logical, they couldn't just use regular numbers and symbols. They had to invent this whole new, incredibly dense symbolic language.
A new language, just for this book.
Basically, yes, formal logic notation, pages and pages of symbols representing logical operators, quantifiers, classes. It wasn't 1 + 1 = 2. It was far, far more abstract. The notation itself is famously difficult to read.
Wait, you mentioned 1 + 1 = 2. If they weren't using normal numbers, how did they handle something that basic? Did they prove it?
Yes. That's maybe the most famous anecdote about the Principia, and it really tells you everything about their approach.
Go on.
They spent years laying down the absolute logical foundations first, defining what a number is in purely logical terms, what addition means logically.
Okay.
And Russell himself famously pointed out that the formal proof for the proposition equivalent to 1 + 1 = 2, well, it doesn't actually show up until page 362.
Page 362 of Volume 1.
Of Volume 1. And even getting there required tons of preliminary definitions and theorems, all built up step by step from those initial axioms.
Wow. Page 362 for 1 + 1 = 2. That just perfectly captures the level of absolute certainty they were aiming for. It wasn't about making it easy.
Not at all. It was about making it irrefutable. Every single step, every deduction had to be traceable right back to those bare bones logical axioms. No hidden assumptions, no intuitive leaps.
They were literally constructing this unified structure where math and logic were the same thing.
That was the dream, yes.
Okay, so let's try and summarize this for you, the listener. Principia Mathematica is this huge landmark, not because it solves some tricky math problem, but because it tried to show that all of mathematics comes directly from pure formal logic. That's logicism.
Yeah, exactly. And they did it using this incredibly rigorous method, starting with a tiny number of basic logical truths, axioms, and building everything up from there, step by painful step.
Using their own special symbolic language to ensure nothing was assumed.
Right. And the big takeaway, I think, is realizing that even something incredibly complex, like calculus or number theory, has to rest on some foundational assumptions. They tried to make those assumptions the absolute minimum, undeniable truths of logic.
It really shows you what the absolute minimum viable truth might look like.
And that idea, the power of understanding and questioning your fundamental assumptions, that's useful everywhere, isn't it? Not just math.
Absolutely. Science, business, philosophy, anywhere you build complex ideas, you need to know what your foundation is.
Which brings us back to the Principia itself. Its entire massive structure was built on successfully deriving everything from that minimal set of axioms.
Right.
So here's something to think about, a question it raises that applies far beyond math. How vulnerable is any complex system, whether it's a scientific theory, a company strategy, a political ideology, if its fundamental assumptions, those starting axioms, are ever shown to be wrong?
Or just incomplete. Or maybe not as solid as everyone thought.
Exactly. How much rests on those first principles? Something to consider when you look at any complex structure in the world around you.
A really powerful thought. The integrity of the whole thing depends entirely on that base. Okay, lots to chew on there. Until next time, keep digging into those fundamentals.